Let's have a look at part B now. So suppose that there's a ad valorem tax, so a percentage tax placed on both goods. Okay, now we want to minimize the loss in efficiency due to these taxes, and assuming that good Y is taxed at the rate of 5%, what must be the rate at which good X is taxed? Now, before we solve this, because we have a certain relationship to keep in mind, let's understand the intuition behind taxes and elasticity. Because what does elasticity show us? I'm going to zoom out this because we have to look at all the data, basically the elasticity of good X and elasticity of good Y to compare them. So we have them like that over here. What does the elasticity show us? It shows us the sensitivity of the consumers, the reaction of the market to changes in prices. Now we know that taxes would increase the prices, and we know that the elasticity would show how consumers will behave based on that. Now in this case we have the elasticity of good X, which is minus 0.12, and the elasticity of good Y, which is minus 0.25. Now let's compare the numbers in absolute values, because we need to know the actual effect size, right? The magnitude, like which one is bigger and which one is smaller. Let's ignore the minus over here. The minus only shows that the quantity demanded is gonna fall, because of course we want to buy less when goods are more expensive. That's all it shows. So if we compare this one, 0.128 relative to 0.25. Well, 0.25 is greater, meaning that consumers for good Y, right, the consumers in the market for good Y react more, they react more to changes in prices. So consumers in market for good Y react more to changes in prices, What do we know about loss in efficiency? What is the loss in efficiency due to taxes? Well, remember we have this thing about the excess burden, because of the taxes we change our consumption behavior. We are forced to buy less of that good because it becomes more expensive. And if we want to minimize that loss in efficiency, if basically we want to make it optimal, then we have to think about in terms of margins, like we do all the time in microeconomics. The best we can do is to make the marginal excess burden for one good equals to the marginal excess burden for the other good. Otherwise, if that doesn't hold, there would be an incentive to charge a higher tax in the good where the reaction is smaller. Anyway, if this makes it very confusing, just keep in mind that we must think in margins, and the margins must be equal to be at the optimal point. We're still hurting consumers because no tax makes no one happy, but the point is we want to hurt them as little as possible. So with that said, we have to keep the relationship between the taxes and the elasticities in mind, meaning that the tax that we're going to charge for good X multiplied with the absolute value of that elasticity, again, we think about the absolute values because the negative signs over here would cancel out, so that doesn't really matter. And it's equal to the tax that we charge on good Y times the elasticity for good Y. And the reason is that these taxes will differ because the elasticities differ. So whichever consumers are less reactive, we can charge more, because the intuition is that they don't really care about paying more for that good. So the excess burden would be lower, the change in quantity demanded would be lower. But on the other side, if the consumers react a lot, if the elasticity is high to change in prices, then they would decrease the quantity demanded a lot, so that would hurt them. So we would not like that. Now, with all that, what data do we have? We have the elasticities, we have the taxes for good Y. So the tax for good Y, it's given to us, that's 5%. It's somewhere in the question over here. Let me just get to it. Yes, 5%, right? So 5% is 0.05. We work with I don't know how to call this in math, decimal numbers or something like that. It's 0.05 because the elasticities are also given in this fashion, right? It's given in 0. And so on. So we have the elasticities of 0.128 for X and 0.25 for Y. So let's substitute these values. The elasticity of demand for good Y is equal to 0.25. The elasticity of good X is 0.128. Make that equal, and we're looking for the tax that we must charge on good X. Now, if we solve the math over here, that tax for good X, if we do all this thing, that tax for good X would be equal to 0.097. And if we convert it in percent, just because it's more intuitive to speak in percent, well, we multiply this by 100, so we get to 9.7%. Now let's see if this works out with our intuition. The elasticity of demand for good X is smaller, right? It's 0.128, meaning that consumers are less reactive, meaning that they are not gonna decrease the quantity demanded as much as the people for good Y. So in that sense, we are able to charge a higher tax on that market, and that's what we do. 9.7% that goes for good X is greater than the 5% tax that goes for good Y, and that stays in line with our thesis about how elasticity impacts the optimal tax. Hope this all makes sense, and we are done.